Hello everybody, this is Snakes, and we're playing Factorio. As I make lots of noise on my desk and move the mic. Alright. So, I had a problem. Have a problem that I'm working on a solution towards. So you see this belt that, this whole thing we've been working on, or I've been working on for a while now, right? What has been happening? Oh. I have two problems. First problem is I no longer have enough output to... darn it. Okay, well I gotta solve that problem before I can solve this problem. So that's kind of annoying. I should make this train stop. Alright, so imagine this belt isn't full for 2 seconds. What was happening was this would get unloaded and start filling up the belt, and then this, since the belt was full, nothing would get on here, nothing would get on here, nothing would get on, nothing would get on anywhere. Keep going all the way down, and then nothing. You get specks, like you kind of see, you get little specks of someone putting something in, but really this guy was the only thing putting anything on there. And since this is always copper for now because of the pickup location, it meant I was only doing copper, which was, which made the other problem of how what was that problem? How this only gets used first, then this gets used in that cascade effect. That meant that didn't help. The two things together didn't help. So what I am trying to do is create a logic network that finds the bins with the most amount of stuff and uses that one first. So the net goal should be that whoever needs to use the belt most has priority in offloading. So what I'm at right now is I have chained all these together. And now this thing has an output signal. It is negative A. It's negative the sum of the parts. So if we go in here, it takes every input, times it by -1, and outputs it as A. This one takes everything. There we go. I'll call that. I think I need to call this B. I haven't really decided what I'm going to call it yet. A works. They both can be called A. This one adds them all together and does that. So now you have negative 12k and then positive 2k over here. Let's go ahead and kill this too. Oh yeah, I killed that there. Alright, so now what I need to do, A greater than 0, output a 1. So what this basically means, if this is, actually let's do less than 0. If this is bigger than that, because if the negative number is bigger than the positive number, then this side would basically need to go, right? So I need to do the same side, same thing on these guys. So we can set that up real quick. Alright, these are arithmetic combiner, arithmetic, whatever the word is. Boom. Boom. And boom. So get green. Oops. I like them in order. And I wish I could do something with this, but that one's just always going to have to go in because I don't have anywhere. I'll have chests for that one. I can't get chests for that one. It looks like if somehow I don't have a good way of doing that. I have chests here and that's it. What I can do, and this would be better, so we'll do it. That goes perfect. And then we start having problems. So what I can do is get rid of that. So it's not as good, but it's not necessarily a bad. At least that gives me something to do math with, at least. Alright, so daisy chain these. Chain. Okay. So this is the decider, I believe. Oh yeah. So, are you outputting any? Oh, output. I want the first ones to be letters, so we'll go ahead and use second levels will be those will be numbers. Whatever the things are called. Alright, so this oh, wait, you're not done yet. This times -1 and B. Oh wait, no, each. Then you'll be called B. And then I want to keep one of these here. I wonder if you guys can hear the wind. It is vicious out there today. Let's see, grab that, go there. Grab this, go there. So hopefully you guys can kind of follow along what we're doing here, because it's the same thing as the other one. Times 1. Outputs. Input each output B. Now you need to be wrong one. Cider. Alright, if B is greater than words. So if this side is bigger than this side, we get a negative number, so this side is bigger, so it should have priority. Now, I have a new problem where, oh, what I should do, go ahead and do that. B less than 0, so I meant. Do I have to do it like that? I could do that. So this will easily tell me which side is bigger, right? So this tells me this is bigger, right now at least. And this is telling me this one's bigger, again, right now. So I could easily hook up this straight to these areas and say, alright, you're bigger, you're open, you're smaller, you're closed. However, I need to do that connected to everybody. So now that these two are saying who's bigger, now I need to decide, alright, well, is this side get priority or should this side get priority? So to do that, I need to compare these two things. And right now, they're both just saying, they're not really saying anything. Unless I set it to this, which I might do. So if I do input count, and I just say each A, B. Do I want to keep it A, B? I might just have them all be A or all be whatever. Well, I might as well all be A. Yeah. I just need to times them by, I need the absolute value now. Or do I? Because I need to do a similar trick to how I got these to show me left right based off negative values. I need to do something similar here, because it's not really easy to compare A to B. How do I want to do that? Okay, I times this by, I don't really want to do that either. Because I have them output 1, how could I use that to give you more information? Because 1s and 0s can only convey 2 pieces of information on and off. So I guess I still need the I need to work with the input count somehow. And how can I make this number tell me more information? So if it's negative, I know the left side is the bigger number. So if I... Is there a way to make things... Not really. Try to figure out absolute value. I don't really have an easy way of doing that here. I just want to compare their absolute value, essentially. So let's make that A. Make that A. And then on this level, if I add these two together and I get a much, let's see. Well, let's play around with it and see what I can get. Need a cider, I think. We're gonna use red as we go over. Let's see, output. Alright, you're still saying A, you're also saying that. So let's go back to you being B. See if I can work with that. Let's just test that theory for now. So input. Whoa, whoa, whoa. Oh, you're connected to the wrong side. Oops. Although, do I want to do that? I don't think so. Alright. So now you're getting the two numbers. Everything is less than 0. I still want to compare them. So if I did this to compare, if I do the same thing, See, I can't times it by -1 because if, let's say, this side's bigger, then this would always give converted to -1, and that would create a problem. If you have two signals, I need you to, if anything is negative, then we would go, which one's more negative? If I could say if A is bigger than B. Ha 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 ha, that would work, right? That should work. I'll put like a 1. Yeah. If A is bigger than B, which is not right now. So... Ooh. That's because they're negative. They could be really big, right? They could be... Because right now negative just means it's the bigger value. Ah, I need the absolute value again. That's annoying. So this is going to show me which side's bigger, but I can't use anything with that information yet. So what I could do is, if I say, assign this B, and don't do this negative, this times thing. Just do times 1, right? So if A is larger than B, output, or just a 1 really. Yeah. Yeah, output a 1. I think this could work, but that may actually be a little bit easier too. Which means I ultimately don't need these. Or do I? I do need those. Let's go ahead and get this back in. Boop. And boop. Boop. U input. No, just times 1. output A. So that's A. You'll be B. Let's go times 1. Alright. Oops. Alright, so if A is greater than B, it put a 1. And then you'll do the same thing over here. Call you C. And don't times -1 anymore. And call you D. And then output a 1. Call that. Ooh, that's a problem. You still need to be input count. I was right. Yeah, I forgot about that. So this let's see, you should have an output. Okay, so if you're not outputting, then we have a thing. Right. Let's go ahead and actually do this. So these lights are going to indicate if on or off, essentially. So right now they'd both be off. What I want to replicate is if... That's not going to work. That's going to turn them on and off at the same time. Oh, enable condition if... 0, right? Ooh, right. Okay. So it's the A is 12K. A bigger than it is, isn't it? Okay. And if that weren't the case, which I can't easily test. Oh yeah, flip it around. I need this to light up when that's the case. So the way, oh wait, you're not. 0. Go away for a second. No! That's the opposite of what I wanted to happen. Oop. No! Alright. So, I think if I got a constant going, a constant combiner, one of these over here. So if you're outputting 0 at all times, and I have you hooked to that. Maybe you should be green. Okay, so you're outputting a 1. You're outputting nothing. Oh, wait. Yeah, you're outputting a 1. Out equals 1. And flip you over. Aha! Alright. So, what we're doing so far is this gets added together, turns into signal A. This gets added together, turns signal B. Add together, or they're compared here. If A is greater than B, this outputs a 1, and that turns that light on. If that's not the case, so B is greater than A, then that's the same thing as just saying this, right? A is less than B. This will turn on because this is constantly sending a 1, and then whenever it's not the case here, you're getting the 1. Wait, why is that the case? Wait a second. Un momento, por favor. Oh, right. No. I forget. Alright, that's right. So right now, since this is true, it's outputting a 1 to both sides, and this is also outputting a 1. So together, this is getting a 2 now. If I put a 2 here, it should turn to, yeah. Alright, that's what's going on. So now that that's working, I need to add another layer of complexity to that, which will be fun. Lots of fun. So now I need to set up basically the same thing over here. That's already set up. URC. Are you done already? C and D. Alright. So let's get new lights. Alright, this guy's a little far away, but I can just I can move it over. Why not? Output. Alright. Input. C. No, wrong one. Decider. Alright, so if shoot, get closer. Excuse me. If C is greater than D, output 1. Can I outdo that? Can't. I want to, because now I somehow gotta compare these two things and do the math somehow there. If you output your input count like that, so you're not gonna do anything essentially. Well, okay. When the condition's met that one's bigger than the other, you're just going to output both of them. That's a little annoying. You can put them... Okay. Well, that's an option. Alright, so if you're 1 and you're that, what I'm gonna have to have another decider because arithmetic's not gonna help. Well, I can do the -1 thing here. Could I? Because there's 2 states it could be in. You could be outputting, or you could not be outputting, right? So one of them's gonna be happening. Either you're out. Let's say they're both outputting. How do I say one is bigger than signal? 1 is bigger than signal. Or I don't have a quantity attached to these signals yet. Could I do like no? That's the only. Oh, you're not doing. Oh yeah, if. But if I said, 0, would it put? It won't put a number on that for me. Let's forget A and B. My concern is when it's not true, it just doesn't tell me anything. So if A is greater than B, and I want this light to go on, and I need, okay. Let's say, actually I want this light to go on. So I need I need C to be greater than A, B, and D. So I can compare C to D, which I've done right here. I could then do other comparisons, but that's a lot of work. So what I'd rather do is compare this C to D, and then compare whichever is greater, so C in this case, to both A and C. But this doesn't tell me anything. Because in my head what I'm thinking is I could do multiple of these. I could get another machine, put it like right here or so, Actually, I can actually do this while I'm talking. I don't have to theoretically do that. This doesn't seem like the right solution, that's why I'm hesitant. Okay, I put this here, right? I could say, alright, is C greater than this guy, which I'd have to hook the there, and then I'd hook to there, right? I could do that, and then they compare, and then they do stuff. But I don't want to do that either. Ooh, okay, okay, well, okay. So if I make this, no, I still can't do that. I was thinking if I went back and made input count again, but that doesn't work. I keep forgetting that because this comparison is only happens if this comparison is true, and I don't want to rely on that comparison being true. Alright, so I need to get fancy. What can I know about these number populations that would help? I really don't care. Because this is the largest here. And this plus this should be larger than this plus this, right? So I find the biggest pair, or okay. So maybe first I should do is find the largest, like treat them as one block. So find the biggest number here, biggest number here, biggest number there, and then make that my first step. Let's try that. That tells me what sector to do. So I say, alright, who has the most stuff out of these sectors? Does that necessarily hold my biggest, who has priority? Because whoever has priority is the guy who has the most, the small unit that has the most junk in it. So, you know, so it has one junk, 0, 0, 0, 0, everyone else has 0, this sector would, okay. But if this guy has 2 junk, he'd have more than, yeah, I think this could work. That could work. Enough to try it. Let's say I daisy chain all this to one thing over here, and then I do a comparison between the sides. And then I could do, yeah, let's try that. I'm gonna run out of colors. Definitely gonna run out of colors. So I can only do, I want to do bigger comparisons first to make things faster. I swear this makes sense in my head. It's hard to transcribe my gibberish mindset into what I'm trying to do. But you guys will see in just a second what I'm doing. Alright, this is an old idea that I don't need anymore. And daisy chain. Alright. So I should probably do this comparison in this spot. Go this way. You have no power there. Sucks to be you. Look at that. Alright, so if I combine this to that, and this to that, take as input everything, times it by 1, and output it as signal A. And then you take as input everything, times it by 1, and you make it signal B. Then, what I want to do is a simple if then. The train's dead, so I can stand here. So this sector is bigger, so what I need to do is get a decider. I guess it can go here. A little messy. This can stay in green, there's no reason to switch colors yet. So A, B. A greater than B. This is actually the same problem, but later, essentially. And if I do that -1 junk, if I make them both the same signal, do -1. That tells you what side to go on. Let's stick with this train of thought first. Alright. If A is greater than B, you're going to do what you're doing. But if it's not, you're going to just give me the not signal. So what I need to do is interpret. Okay, I can rotate that. Cool. Interpret a lack of signal to mean something. So let's output a 1. So what this 1 needs to do is tell all these things to turn off, and maybe these to turn on. Maybe. Not quite do it yet. Just maybe. Are you part of the... You're not close enough. Actually, you can just... No, you can hitch a ride. Ooh, who can you grab to? I guess you could... That's a lot of traveling for a wire. Yeah, get this wire to go somewhere else. I'm not sure where it's going to go yet. Maybe if I move this to over here. Actually, middle should go here. Alright. Right through here. Let's get rid of this old concept. I don't know if that's the best spot for it either. Why is it? Oh, my pick broke. This. So, this is the decider. That's my decider. You go here for now. You go there. You go there. This network goes in here. This network goes in here. You take everything, times it by 1. Will that work? It did. And then you'll be called A. You'll take everything, times it by 1. Not 10, 1. And you'll call it signal B. You guys will output to your input. You'll output to his input. That sounds fun. And then if A is greater than B, output a 1 on the 0 channel. As we can clearly tell, A is not greater than... Oh wait, no. What? Oh, I switched them. I don't want this one to be A. This should be B. Alright, so you can clearly see B is much larger than A. So with that information from this, where your lack of signals needs to tell someone else something. So maybe you should tell someone over here something. If I give a constant combiner, let's get some fake lights up here too. Actually, no, you can. You're for that one. You're for that one. You're for. Actually, you would do. You're for that one. You're for that one. Right. So what I would want to do is now send the off signal to everything up here. So how would I do that? A simple if then would work. So, you know, let's do that. Let's go ahead and mirror this, because I think this is going to be the better approach. Alright. So, middle's here. That goes there, that goes there, that goes there. No, these are deciders. Oops. Alright. So all this goes to asthmatic, right? Why are you? Huh? You together here. You should go to him. Ah, okay. Yeah, that's a little confusing. Maybe I should do that. Whatever. Alright, all that goes into you. Your output goes into this guy. Did you guys not get daisy chained yet? No, you didn't. In fact, you should also be daisy chained here. No! Okay, let's make some more green wires. Alright, one. No, would you kindly actually go where I click? Alright. And then your input goes into, or your output goes here. Yep, cool. All these together get times by 1. 1. Would you? Thank you. I don't need that. Output. You can output a 1. Ooh, so how do I know which one's bigger between the two? Because I know if this side's bigger than that side. Ah, okay. So what I want to do now is a red chain. Which side's bigger? Okay, we're getting somewhere. Somewhere fun too. Is this all of them? Oh, I didn't realize. I thought I had an even amount on both sides. I don't. So let's see. No, I was thinking I could break this sector in half, but then that makes a mess later on. Why is it? Oh, okay. Regardless, the bigger sector is still gonna go once I do the math right. So, first step needs to be which side's bigger. So to do that, that's all the reds. Actually, can you guys get? Oops. No, can you give me some copper? Try to make it on myself. Alright, so that's all my reds together. Thank you. Okay. So, do you need a combiner? I guess I do. Yeah, let's get some combiners. Doom doom. Red here. Red here. Take everything. Times it by 1. Let's go ahead and just call that K. That's not confusing. It's very confusing. It's just the next row of vegetables, of letters. Sorry, being a little lazy. Get a decider going. And this needs to be in range of U. So here, unfortunately. And take the red. Go here and there. If K is bigger than L, I'll put a 1. So L is much bigger. That's fine. So this I'm gonna make like a I need a hub like right. It's a No, just a 1. And make that the... It's a wall, I guess. That'll be... the M signal. So... Hey, let's get more lights. Actually, yeah, you won't be that signal. It'll be... I don't know. I don't know if I want the green signal on. Yeah. We'll do green. No. Indecision 2020. That's 3 away. And what you'll do, you're the red one. And we'll get a constant. I find the lights really help me know what the heck things are doing. So this one constantly be outputting a green. Value of 1. Let's go ahead and make it red. And you'll go to this light. So you're putting a green. These colors. Enable condition green is equal to 1. And you'll be green is equal to 1. Flip that. Cool. Alright. So now, whichever side's lit, this is how you get it lit. You send these 2 signals to it. If it's not lit, then this is... Okay. So if I want all these to light up, or if I want all these going, I just copy these signals to the head bosses. Not quite what I want. I want, if this is going, to then do a comparison between these 2 populations. Which is hard to do when we got sectors going. Okay. So no, I need to do this sector versus this sector. You're not part of both, so what? 4. Okay, cool. So now you need to see if this side is bigger than this side, and this side from that side. So I'll take this. This is what this does. So let's make a new light. Doop, doop. And I guess over here. I want to turn this light on when we find the biggest sector. So I guess this light first. Alright, so you do your thing. You're comparing... No, I need to compare these 2. So this doesn't matter anymore. Alright, so now, compare these 2 sides. A couple ways I could do that. I could say, nah, let's do it the straightforward way, because I think that makes the most sense. Alright, so I need the arithmetic combiner. I need to get rid of... Let's see. I don't need... I just need these things most of the time. I rarely need this. But I don't need pipes as much. I can put pipes back. I don't need that. I can go there though. Alright. Alright, wait. Boom. Maybe that should be there. Yeah, I have space. Alright, so I need that to go here and here, and then I want... I need to go get a protein shake. Let's get this proof of concept going, and then we'll make a break for protein, and then I'll be back. Alright, so this is my arithmetic combiner. I need to test this population versus that population. So I guess here and here. Can I have robots on? I only don't like robots because they get in the way of things, but right now they can be useful. And a decider right here. So let's take this. Hook you in. Hook you in. Each times 1. Call it. I don't think I did A yet. Call you B. Each 1. Alright. This goes to your input, which goes to your output. A larger than B. So B is much larger. Really? Okay, I guess so. Yeah, that makes sense. So this needs to do the same thing we did before. Here. So your output is going to be yellow. Well, I can do blue. Blue's fine. And your output's also going to be, yeah, both of you going to output blue. And you got to get all the way over there. That's fine. So when this is bigger, you're going to output the blue 1. So you can go straight to that. So I'll go. Why? You're saying no. Use color. Blue equals 1. Okay. Which is true. This is okay. This is good. This is good. All right. For a second, I was panicking. Wait a second. I thought that would be true. It's not true yet. This one's true, on the other hand. Ah, darn it. Who's powering you? You should. Oh, and now it worked. Okay, that made sense. Blue equals 1. These colors. And you should be outputting a constant blue. Oh wait, now I can't walk past this. Oh no. That's fine. So that turned blue now? No. That did. Wait a second. B is greater than A. This is A. Oh, they're backwards. Okay, let's flip that around. A and B. A greater than B. Besides A. That's a weird color to use. I don't know the color to use. That's fine. That's fine. I'm not worried about it. I'm just concerned that A is bigger, right? So you're outputting a 1, which is turning you on. But instead it's turning this one on. Alright, so you're outputting a 1. You're outputting a 1. So you're getting 2? Is that what's happening? Let's flip this around. Do they both turn on? No. How are you getting the one and you're getting... Okay, it is this. So what we'll do is we'll put you on the red circuit. Which I think is wasting a circuit, but that should be alright. Ah, right, you're not doing anything. Blue 1. Yeah. So... No. Maybe that didn't actually do what I thought it would do. So since it didn't, let's go ahead and try to get it working on the same circuit. Alright, so you should be getting a value of 2 right now, I think? No. Equals 1. You're both getting a 1. So now you're both off. Okay. Wait, so that should actually, it'll be fine if I turn you back to, no. A greater than B. You're also getting that value. Okay. Yeah, so you shouldn't be getting that right now. How does that not work over here? Because you're not connected to that. Okay. So I guess one should be red, one should be green. Whoa. Alright, now let's see. Yay. Alright, so this sector now has the big one. So now I gotta divide it by 2 to find which sector is bigger than between these two. And here's where it becomes a little tricky. I've used all my colored wires. Alright. Like I said, I need to take a break. I'm going to think about this a little bit, figure out how I'm going to take account of just these items and compare them to just those items. Hopefully it'll work out somehow. Alright, yeah. So I'll see you guys. Thanks for watching. Later.